Hello, good morning to all and welcome to our session for Asia Water 2020 Technology Symposium. Before we start, there are a few rules that we'd like to add here. All microphone and video of attendees have been muted. If you have any question, please wait for the Q&A session or you may list them down at the Q&A box. If there is any internet disruption during the session, kindly be patient and try to sign in again. In this session, we will have Mr. Dietmar Gillich from Meister Asia Pacific to do the presentation. Sir, the floor is yours.
Thank you very much for your introduction. Hello, good afternoon, everyone. My name is Dietmar Gierlich. I'm speaking to you today as the appointed managing director of the company Meister. Meister Asia Pacific, located here in Kuala Lumpur. Although my name and also the company name hints you, complicated as it is, it's a German name for me and also a German company name, German company. Within the next 20 minutes or so, I'd like to talk to you about the advantages of variable area flow meters. So we jump right into it, and my slide goes on. Starting with a definition of what is a variable area flow meter. Here I like to quote Mr. Liptak, where he says that the area open to flow is changed by the flow itself in a variable area flow meter. Either gravity or spring action can be used to return the float or wane as the flow drops. So that is one possible definition of variable area flow meter. Different people would have different definitions, and indeed many people have a quite different understanding of what are actually variable area flow meter. So today here we start with a bit of an overview theoretically, where we would have here on the very left hand side the tapered tube variable area flow meter. I believe those are most common. Most of you have seen such, mainly produced with plastics material, probably the most basic type of variable area flow meter. Then here we would have another area called the tapered plug, where as the flow comes in, bottom up in this case, which can be any media, let's say water. Water would come in and would push up this this cone here on the very left and very right of the pipe. There would be an orifice, so the water would have the chance to escape then as we push up that cone. In this case, we have a parallel tube with a tapered plug. That's another quite common style to build variable area flow meters. Then there would be a third style, according to Liptak here in his book, where the piston is in a perforated cylinder. So here would be the piston, which is again pushed up and down, and the higher it is pushed, the more water in this case could escape left and right around the float. And here in his definition, also a flexing vane or disc or flapper, as he calls it, would fall under the definition of a variable area flow meter, where probably here the dispute starts latest at this point, where not everybody would agree that these are still variable area flow meter in common language, but would then rather be called disc type flow meters. In this range now, I like to add one particular type of variable area flow meters, which is now an invention of the company Meister, which we call the Meister slot nozzle. The Meister slot nozzle still or also falls under the float measuring principle, Here also I like to bring in the term rotameter, which is heard often, which would apply here to the very left style, very left type of variable area flow meters. And here in the Meister slot nozzle, we do have this value-adding combination of a few advantages from all these different systems. Like we do have a cylindric outer shape, which keeps the float inside in a guided path, which is an advantage, as it cannot edge, cannot get stuck. While at the same time, with our slot here at the very bottom, we can see that, which we can design in many different ways and shapes. That would allow us to have a similar effect like having here a tapered tube, so that the measurement range which we can measure with our flow meters is then very wide. I'm blending in now one of our flow meters to see how this slot nozzle is built in to the outer case. So, talking about the advantages of such type of flow meters, we would first have the simple design, which I like to highlight. A simple design means there are really just a few components, a few parts which we have to assemble, and it works already, which makes it, as a result, quite cost effective. A next advantage would be the relatively low pressure drop. Here we have to look a bit into more details, and we have to differentiate when comparing to other types of flow meters, because in our case here with variable area flow meters, there is still a float inside the stream, inside the flow, which does give a certain resistance and leads to a pressure drop, which is undesirable, because it means that you have to calculate for a higher pumping power at the very beginning, which again costs money. So here we have to see and compare our flow meters to the various different other types of flow meters, where other types do not have anything in the pipe at all, would allow a free flow of water. In that case, the variable area flow meters do not have this specific advantage. But then there are again other types of flow meters. Let's say the volumetric gear type, some impellers, turbine flow meters could have then their a higher pressure drop. So here it's a relative advantage to those kind of flow meters. Another advantage of our variable area flow meters is that we do not need a power supply. That results in a reduced overall cost and time for installation, because our flow meters, they work with physical basic principles only. It's gravity or spring force, which brings the flow down and makes accurate flow reading possible. A quick installation and maintenance is another advantage of such variable area flow meters, because it is really plug and play only. There is no parameterization which you would have to do up front to make it running. It's plug and play, screwing it into the pipe, and immediately you can read out the flow from the flow meter directly. So that saves time and efforts. Another advantage is that these flow meters can produce with the highest grade material. We have stainless steel with the European code 1.4571, or the American standard would be the 316 Ti with added titanium. So that can be used for high temperatures and with most aggressive media. That's another advantage that makes our variable area flow meters very versatile in all different environments. All media types can be measured, not only water, but also oil. So viscosity can be compensated. Different gases can be measured. That makes these type of flow meters hassle-free, easy to use. It's an easy to understand system, I would say. There is no doctor degree necessary to to install and understand the basic principles, which makes maintenance also quite easy, replacing parts and understanding the system and seeing, recognizing if something goes wrong. Standard pipe fittings can be used, so there is no worrying about necessary straight runs as well. For example, ultrasonic or turbine flow meters would have a bigger need of certain pipe lengths before and after the flow meter to relax the flow, whereas our variable area flow meters are flexible here again in the installation point where in the piping that happens. Little friction would be applied here. There's no big mechanical movement here. The float that we have with stainless steel is floating in the water. So the only friction here is really between the water and the stainless steel float, which is reliable and sustainable over decades, not just years. Yeah. Which also leads then to a high repeatability over a long time. So in our piping system of advantages, we come to the advantage that flow reading can happen at the point of the installation, as there is either a glass tube or an attached flow indicator mechanically with a magnet. And when we have this glass site, this glass tube that allows to check the media itself to see if there are bubbles in the media, if there's dirt in the media, which could indicate that the filter would have to be changed. If the color is changing of the water, or to see if there is a flow at all, which is another important point in terms of reliability of the whole system and installation. We do have applications where our flow meter is used as a backup to check the performance of then other flow meters. Other flow meters would have other advantages, as for example, you could measure more accurately with other types of flow meters. However, those mostly electronic measurement principles then do have the advantage, the disadvantage that you can't see directly with your bare eyes if there is a flow at all, for example. So you can't really validate if the reading, the electronic reading that you get from another more accurate flow meter maybe is feasible at all. So that's a whole set of different advantages of variable area flow meters in general, which brings me to the advantages of using the specific Meister slot nozzle. Here, in the first place, I would have to mention the big and wide measurement range at the smallest size, which can go up to 1:70 in that ratio. In this picture here that I've zoomed in this example from that particular flow meter, we can see on the scale a measurement range from 1 liter per minute to 45 liter per minute. So as I said, that could go up in our current catalog standard versions up to 1:70 in such ratio, which is very wide. And if you consider that our flow meters are relatively small, that is one of the key advantages this system. Another design advantage with our installed spring is that we can install our flow meters in all angles, not just vertical. Finally, another big advantage here is that the measurement tube is parallel, cylindric, which allows the float inside to travel smoothly in a guided way, which cannot get stuck and edge, which is a common problem with the tapered designed rotameter. So that ensures a reliable measurement over years and decades. In this final picture already, I want to give you a quick look into the various types of variable area flow meters that Meister has on offer. We see here flow meters with a glass tube. We see flow meters more in the back with an attached external display, which is with magnets attached to the float inside. So it still does not require a power supply. We do see in this picture that it's possible to have a switch contact, which customers can adjust easily, and every mechanic can set that set point by themselves with a screwdriver. No special training required, I believe. There can be one switch contact, there can be two switch contacts at the same time on one flow meter, one measuring a minimum flow level, another switch contact measuring a maximum flow level maybe. If you wish, you could even make a third switch contact. But then also there are output options of an analog transmitter, which gives you the standard 4 to 20 milliampere or 0 to 10 volt output. That is the option we would see in the back with the small blue box attached, M12 connector. The latest product development then of Meister would be the digital output option, which you can see in the picture here in the front or also there, which gives an output signal not anymore in the traditional analog world of voltage and current, but communicates the flow value now based on a digital protocol. We use the IO link standard. So that has various advantages when we now go into the next development step, accompanying the fourth industrial revolution, that we are working more and more with digital data. Because later on, as the signal information goes along the automation pyramid from the very bottom, from the signals over the PLCs and SCADA systems and human machine interfaces until software programs, it will end up anyways in digital systems nowadays already, where finally a computer is managing all these sensors and information. So the earlier the digital information comes into that chain, the bigger the advantages of having a reliable signal without dealing with the disadvantages of analog data transfer, which is not as reliable, not as accurate. So here I'm happy to talk more with you. I'd like to invite you to meet me at the Meister booth. I'm here today, full day, tomorrow as well. We would be able to talk in detail about the specific solutions for your specific applications. I'm very happy to talk with you about the different signal types that are on offer. analog and digital, especially nowadays. I believe most people have questions in this regards. But I'm also happy to introduce to you later at our booth the options to print, 3D print your flow meters for your application. You find videos and more information material in our booth, where we are now entering the area of 3D printing since several years already, where we start to print more and more of our parts. So I believe that is all from my side at this moment. I'd like to thank you for your attention and invite you to meet me later at the booth. For the moment, however, if you have any questions right now, I'm happy to answer that right away and open the panel for Q&A.
Thank you, Mr. Dietmar. Ladies and gentlemen, we have come to a Q&A session. If you have any question, you may click on the hand raise function and organizer will unmute you. You can list down your questions on the Q&A chat box. Please make sure to introduce yourself and which company you're from, followed by your question. Mr. Dietmar, we have one question from the floor. Oh, we have two actually. So the first question is from HKYO. At what range of sizes will your flow meters be competitive?
The standard catalog ranges that we would have available immediately up front today would start from a 1/4 inch over 1/2 inch to 1 inch and also 2 inch. So until 2 inch sizes, that would be the catalog standard. However, there are possibilities beyond that, especially when we talk about customized 3D printed products that I've mentioned before.
Okay, so next question is from Sabrina Ng. Is your flow meter material suitable for chemical medium?
That's a good question, thank you. Basic, easy answer is yes. As we have in our catalog 2 standard materials available. One would be the brass option, and the other one is the stainless steel 316 Ti. We know that we have many customers in the petrochemical and other chemicals industries, dealing with many various types we have come across over our 36 years of existence meanwhile. So definitely the answer is yes, chemicals are possible, many different types. Of course, then when we look in the details, we would have to see what media we are dealing with, as we still can make changes, as we still have variations in the material that we use. We could also provide colonel material, for example, and others as well. So that depends a lot on the actual media. So you're welcome to challenge us with whatever media you have.
We have one last question from Yok Fah Wong. Does this meter need verification to ensure its accuracy?
Does it need verification to ensure accuracy? If I understand that question correctly, I would answer that as we supply our flow meters, they are ready to use, plug and play. There is no recalibration necessary at your point. Once we send that out, we ensure our catalog specifications to take the flow meter out of the box and straight put it in the machine to meet the requirements as stated in our specification sheets. Maybe one more addition to that answer. As we then look at maintenance over time, that's maybe another interesting point here when it comes to calibration, where I like to mention that these variable area type flow meters typically do not need recalibration over time. for decades, you would be able to run it without a change in its accuracy. There is no such thing as a yearly recalibration of such flow meters. In contrast to, because I understand the question, this regular cleaning and maintenance and recalibration, I do understand, is necessary for other flow meter types. For example, let's say volumetric gear type flow meters that do have a lot of wear, a lot of mechanical friction and movement. They do need regular recalibration, to my knowledge, although I'm not an expert here. Some manufacturer of such flow meters might prove me wrong, but generally that would be the rule.
Perfect. So one last question from HKU. Am I right that variable area flow meters do not handle slurries well?
That's a good question. For this, I would say that most manufacturers of variable area flow meters do not have a clear KPI, let's say, or a clear benchmark on what type of slurry media you are still able to use and to measure with your flow meter, because it depends on a lot of KPIs. Depends on the viscosity, let's say. It depends on the temperature. It depends on the hardness of the particles, which contribute to friction. So there's no clear guideline in the market, I would say. Also in our Meister catalog, there would be no clear benchmark on what type of slurries you would be able to handle it. This would really go into an area of one-to-one individual consultation to see what area do you have, what media do you have, what slurry types do you have, and to what range our flow meters would still be able to handle that. So there is no clear yes and no to this question.
Okay, thank you very much for the explanation, Mr. Dietmar. We have come to the end of our fourth session today. We hope that today's session, all your questions are being answered. If you have any other inquiry, please visit Mr. Asia Pacific Sdn Bhd booth in our virtual exhibition hall. That's all from us. Once again, thank you, and please stay safe all the time.
Thank you.